Welcome to the ninth session of Electromagnetic Theory and Interference course. In this session, we are going to see one of the fundamental law, that is Coulomb's law, which is going to govern the electrostatic field. So, before moving to the Coulomb's law, let us understand how the electrostatic fields are produced. They are produced by the charges at rest or static charge distribution. This electrostatic field of principle are used in many applications ranging from CRT to X-ray missions and solid-state devices like resistor, capacitor, transistors, and computer peripherals and medical ECG, EEG, and wherever I need to record the electrical activity of organs, and in industry to for paint spraying, electrodeposition, and electrochemical machining, separation of particles in agriculture to sort out the seeds, to spray the plants, to measure the moisture content in many ways. So, what is the difference between the two laws? In Coulomb's laws, I can find the electric field due to any charge distribution, whereas Gauss's law is one of the other fundamental laws that is governing the electrostatic field, where I can use this law to find the same electric field, but one condition is my charge distribution is symmetrical. Okay, now let us uh, go to the Coulomb's law, but before that, we have to understand few things. That is why the Coulomb's law is used to find the force between the two charged particles. Here, the two charges are point charges, that is Q1 and Q2. Why we are calling these as point charges? Because its dimension is very smaller. Okay, and electron is one of the point charge. The charges may be positive or negative in nature. So we already know like charges repel and unlike charges attract each other. How will you measure the charge? By means of coulombs? So 1 coulomb is 6 into 10 power 18 electrons. From that I can compute the charge of electron, which is nothing but 1.6 into 10 power minus 19 coulomb. So what is the Coulomb's law states? It relates the force of attraction between the 2 point charges, attraction or repulsion. So it should be along the line joining them. Okay, it is related directly proportional to the product of the charges and inversely proportional to the square of the distance between the two charges. So Q1 and Q2 are the 2 point charges that we have taken into consideration. This is my Q1, okay, and this is my Q2, and the separation between the two charge particles is nothing but capital R. So here the K represents the proportionality constant because we have removed that proportionality symbol, right? So the value is 1 by 4 pi epsilon naught. If I substitute the value of permittivity of free space, that is epsilon naught 8.854 into 10 power minus 12 farad per meter, I will get this answer. Okay, for the K value 9 into 10 power 9 meter per farad. So what is the unit of force? It is nothing but Newton, right? Now we are going to substitute the value of proportionality constant in this above expression. Okay, in this above expression, we are going to replace the K value. So it is nothing but 1 by 4 pi epsilon naught Q1 Q2 divided by R square. Suppose if my point charges are located at a points with a position vector R1 vector and R2 vector, and the force on Q2, okay, this is the last point represent at which charge my force is acting due to Q1 is given by Q1 Q2 divided by 4 pi epsilon naught R square. I have to include the unit vector AR12 cap. Okay, this is the line joining the two forces, so that is vector. So R12 vector is R2 minus R1 vector. So if we have to substitute the value of AR12 cap, it is going to be the vector divided by its magnitude. The magnitude I am not writing like this, I am just replacing by capital R. So if I substitute here, because already the magnitude is there R square, if I substitute for a unit vector, I will get one more R, so RQ into R12 cap. So if I consider these vectors small r1 and r2, I can write it. So r12 we already found that it is r2 minus r1. So that vector divided by its magnitude r2 minus r1 the whole cube. So we can We have seen the force on Q2 charge because of the presence of Q1 charge, that is F12 vector. Now let us see how to find the force on charge Q1 due to the presence of charge Q2, right? So to do that, we are taking the magnitude of the force on Q2 because of Q1 charge, and we are going to multiply with the unit vector AR21 cap. So in that case, then we can see if I want to replace the unit vector by the previous unit vector, that is AR12 instead of AR21, I have to put a negative sign because the unit vector is moving in that direction, right? So the magnitude remains the same, only because of the direction of unit vector we get a negative sign. And see here, the charges that we are considering should be at rest or in static nature, because we are studying about electrostatics, and all the charges are point charges. And one more thing, here the charges, you should know that it cannot be created or destroyed, but the quantity of total charge always remains a constant. So till now we have seen 2 point charges, right? Now let us consider a case where if there are more than 2 point charges are present, what we can do? So we have to apply the principle of superposition to determine the force on a particular charge. So here, what this principle states, if there are n number of charges like Q1, Q2, etc., Q1 located at the points position with position vectors R1 vector, R2 vector, these are all vectors, the bolded letters, R2 vector and Rn vector. The resultant force F on a charge, particular charge I am considering, located at a point R, it is going to be the vector sum of the forces exerted on the charge Q. Okay, the vector sum of the forces exerted on the charge Q by each of the other charges. Okay, this is the vector sum. Because force is a vector, right? It has particular direction. So how will I write? It is just 1 by 4 pi epsilon. So you can take, so the charge I have considered is Q. Because of Q1, so Q into Q1 divided by 4 pi epsilon naught. I have to multiply the vector and the numerator R minus R1, and I have to take the magnitude of the same as a Q. Similarly, I have to write for the other forces. This is due to the first charge on the charge Q. How my force set? This is force on Q due to Q2. This is force on Q due to the charge Q1. So what is common here? This Q by 4 pi epsilon naught is common. So I have to take it out, and I can write everything in a summation. What are the things? This other charge Q1, Q2, that it varies, right? So QK I can put here R minus RK divided by R minus RK, the whole cube. These are the vectors, right?